Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina. Aaron, welcome back to the show, man. It's been a little while.
Yeah, absolutely. It's good to be back. I apologize to everyone out there. And yeah, we've had a little bit of internet difficulties today and Skype difficulties, but we got through it all and we're back.
Yeah, so good to have you back. Maybe we may get a little streak going here, but I know we're both traveling a bunch. So anyways, we talked for a long time about doing a show around serverless, and the intention is we're still going to go and put together a show around serverless. We are running into a few more things that we had to, getting those Swiss bank accounts set up is a little tougher than we had planned, and some other stuff. But we promise we will get the show out the door probably around the time of the serverless conference. It's coming out in the UK, so keep an eye on that. But in the interim, we decided there's no point in not talking about that topic. So very excited today to have Chad Arimura, who's founder and CEO of Iron.io. Chad, welcome to the show.
Hey, Brian. Excited to be here. Thanks.
So you and I got a chance to meet this summer. We were out in San Francisco at the Red Hat Summit. Give folks a little bit of your background, with Iron.io and with the technology, because you guys have been doing this for a lot longer than the buzzword's been around. And, give us a sense of where you guys have come from and where you're at today.
Yeah, the Iron platform. So my co-founder and I were running a development shop back in 2009, 2010. And we really scratched our own itch. So we had 7 or 8 developers working for us at the time. We were trying to ship software for a number of clients that were pretty demanding. A lot of the customers that we had were IoT-like use cases where they'd had networking devices and solar panels and bicycles sending in data. And we would collect this data, aggregate it, create systems out of it, and created a platform that would automate this whole matter of shipping code to the cloud and doing ETL transformations on the data and building graphs and charts and PDFs. And so what we did was we built a multi-tenant system that our own developers could use and write small bits of code, zip it up, send it, and it would just run. And it would do all the load balancing and networking and spinning up of servers and infrastructure and connecting to databases. And that all happened on AWS. And then one day, one of our customers called and said, we're migrating to Rackspace. Can you run there? And so that was the beginning of what we call a multi-cloud, hybrid cloud, serverless platform.
Okay.
So fast forward a couple of years, we founded the company Iron.io in 2011 because of just developer interest in the service. And we wrote an article in 2012 called The Future is Serverless. So we put ourselves on the map a bit. We have proof that we were talking about serverless computing, even though it was a very controversial topic at the time. And now it seems to be one of the biggest buzzwords we've heard in years. So it's pretty exciting to be in the epicenter of it.
Yeah.
Yeah. And so Chad, I have to ask immediately, before we even get into any of the technology or anything, how do you feel about the term serverless? Because, boy, it's polarizing.
It depends on what perspective you take. So I, as a developer myself, I'm a firm believer that I never want to have to think about servers. But the first misconception is obviously it takes a lot of freaking servers to run a serverless platform. We have thousands of VMs at any given time spinning up and down behind the scenes for our customers. And so it does take a lot of servers. So the term as a misnomer is not a technical architecture term. But I think what it does is really encapsulates the abstraction layer of where we're going. If you think about even the movement towards containers, you're still thinking to some degree about where you put those things, virtualization on top of hardware. But with serverless, you're really just writing a piece of code and shipping it, and it just runs. And so this construct of not ever thinking about any of the servers underneath it's really a state of mind, first and foremost. So I don't mind the term too much.
Yeah.
There you go. Cool. And let me ask you this then. So as this serverless movement kind of is really gaining as much momentum as it has, I mean, it really has been amazing, but we've seen Iron.io mentioned more and more with a lot of other platform companies that are out there. So tell us the basics of Iron.io and how does it really augment, serverless in general in these platforms as well?
Yeah, so we have been running the company for 5 years, and our traditional go-to-market has been around a hosted model where we host the platform on top of AWS and Azure. We have some customers on Rackspace still. And that was a great business, but I think what we saw the trajectory of the company was moving more into the multi-cloud, hybrid cloud, private cloud world. So if you're spinning up a cloud in your own data center, you want the same API to handle your serverless computing as you do in the public cloud. We provide that serverless abstraction API to run workloads equally, both on premise and in the cloud. And as we looked around the market, there are a number of technologies that are becoming very forefront as part of what we're calling the modern enterprise stack. Those technologies are Kubernetes, Mesosphere, to some degree Docker, Docker Swarm, but we're also seeing Cloud Foundry and OpenShift as well. And so as we looked at the private cloud and hybrid cloud market, we said, we need to play very nicely with these because at the top of the stack where the serverless workloads are happening, we can use those orchestration layers and platforms to actually run our runtime and orchestrate the work that goes into the underlying hardware. So as this modern enterprise stack forms, we really look at ourselves as almost the Switzerland of serverless computing at the top.
Yeah. So you guys, in essence, are having to do some integration or have some awareness of the Kubernetes, the Mesos, the Swarms, the various sort of container orchestrators to, as requests come in, you want to be able to spin up those underlying resources below you if people want to, also use those types of platforms for other workloads, I would assume.
Exactly. When we first built the technology, none of these things existed. So we built our own orchestration layer. We run on bare metal. We run on VMs. We run on OpenStack. Just give us some VMs and we can run anywhere Docker is supported. However, as these orchestration frameworks came into play, we looked at them and said, they do a great job of resource allocation. We can just deploy Iron as an app right on top, and our runtime runs right inside their pods or nodes or whatever the construct is called.
Yep. Yeah, no, that makes sense. So, you guys were sitting there 4 or 5 years ago. People looked at what you did, however they did. It was an events-driven business. It was whatever. Now all of a sudden, there's all these frameworks on the marketplace. There's Lambda and serverless framework on top of Lambda. There's OpenWhisk. There's Google and Azure functions. If you can, give us the basics. How should people think about just kind of, events-driven, serverless sort of frameworks? What are the basics that people should be thinking about, and what tend to be the core or most important kind of characteristics and takeaways that people, look to as their, big decision criteria?
Yeah, I mean, part of it comes down to simplicity of design and form and function. So at Iron, we've always believed that simple APIs win. And simple abstractions win. And so if it's a beautiful user experience, if the developer experience is clean, if you get this sense of multi-cloud control and choice and flexibility for your workloads, but in an ease of design, that's really what we look for first in a service. There, obviously, you named some pretty great services out there. Lambda is obviously driving a lot of the education in the market. It's almost now synonymous with the word serverless, which has been interesting to watch. The one hold up, obviously being biased ourselves, is that we sort of come at it from two major differentiators. One, we believe that serverless workloads should be abstracted away from the cloud itself, so not tied into an individual provider, but actually run on top of any provider, including on-premise as well. And that should be a single serverless API. And two, we also believe that it should be containerized as a first-class citizen. So if you're using Docker, we'll support future container technologies from the OCI. But because Docker makes it so convenient to include any library or any stack or any platform, you can support almost anything that you can possibly think of to containerize will run on our platform. However, if you want to skip the kind of cognitive overhead of having to deal with the container system, you can just use our CLI and we'll inject the zip code package right into the container and run it as if you never had to deal with it. So that's a fundamental difference for us. But you're right, there are a lot of options, and it's interesting to watch how this market evolves.
And Chad, what has been kind of the emerging trends when it comes to workloads that run within the framework of say Docker versus OCI versus kind of anything else? Like, how do they fall in? What is the majority of the trends you're seeing right now?
In terms of the use cases?
Yes.
We have historically been, and in fact, to this day, are still 100% asynchronous, meaning when you kick off a function, we call it a worker. When you kick off a worker, our API returns a 200 OK, and that work goes and does something. And then you can execute thousands of these concurrently, and it's a job processing, batch processing platform, serverless to the developer, but very asynchronous driven. Those workloads very typically are greenfield applications, microservice type applications where you're containerizing smaller and smaller pieces of code around image processing, ETL and data transformation, asset processing, video encoding. And another popular one that's emerging is obviously Internet of Things or IoT. It's at the DNA, the roots of why we built the platform. Data comes in, do some stream processing on the data, run functions across that data, push it out into other data storage services, pull and mash that up with other third-party data. These are very popular asynchronous use cases. What we're now seeing is a trend towards synchronous use cases. We'll be adding synchronous support to the Iron platform shortly. And with that, sort of the world is your oyster. You can now build serverless APIs on top of a serverless architecture, which is a really powerful combination, both synchronous and asynchronous.
Yeah, what would be an example of maybe some of those synchronous types of patterns that you're seeing? We've heard in the past certain frameworks, don't want to run things for long periods of time. They're more short run types of applications. What types of applications or patterns are driving that synchronous requirement?
Well, the key difference is that when you hit the API, it actually returns a response from inside the function. So if you need to generate an immediate response, an API is the perfect example. If you want to pull a GET request on an API on a data storage service, you want to get back a result, you want to do a image facial detection and return the coordinates of the face on the image, or you want to return the characters from a license plate in a detection service, you generally want to get those back right away so that you can actually return those back to the user or operate them in some kind of a workflow. That's the key difference between the synchronous and asynchronous model. Synchronous will return, for example, a JSON payload that will actually send back the response right away. And now you can start to build very intricate applications around serverless APIs where you build a complete abstraction as an API in front, and those are kicking off functions in the back. And we're no longer running applications 24/7 or having to run long-running apps. It's simply calling the endpoint and literally lighting up 100 milliseconds worth of compute and then going away and freeing up that resource to serve some other request in a future point.
Gotcha. So it's sort of a kickstarting the beginning of potentially a bunch of microservices downstream that could be doing a whole bunch of anything. You can sort of chain them together in various ways, and that's cool. So we've talked a few times on this show about some of the technology. We've kind of dove into some of that, but on the flip side of stuff, you guys have been doing this for a while with customers. What does the business conversation look like when you're talking about these types of applications? I mean, I obviously when it's a hosted service, you're charging people at a much finer grained level than you do for things on an hourly basis or whatever. But help somebody understand what the business language is, the business conversation that goes along with serverless.
Yeah. First and foremost, the conversations that we have with customers is primarily driven by innovation and flexibility for supporting the delivery of code quickly. So the big thing around serverless is that it empowers developers to ship code very quickly, have to think about code in very small fragments, not have to deal with big monolithic applications. So we're now deploying code to the cloud hundreds of times per day even. And we have, the classic two-pizza team where you have small teams innovating, shipping code very quickly. That's number one is developer empowerment. So when you think about it from a business perspective, it's not just about the dollars and cents in terms of how much you're paying for compute. It's also about how quickly can I empower my developers to respond to market demand. That's number one. certainly a big part of serverless compute and a big trend towards this abstraction layer is that we're now calling compute in increments of milliseconds and not running servers 24/7. And that's really shifted the economic model of calling up compute on demand. So you mentioned event-driven computing. That's a very, I would say, subset of serverless computing where event-oriented actions will trigger functions, which then call up the resources in real time, as opposed to having a service wait around 24 hours a day to be called upon from that event. It's a very revolutionary economic model where we're literally paying pennies now for what we used to pay dollars. So it's a pretty powerful construct, and that's, I think, a big shift in the business model of this compute architecture.
Yeah.
And Chad, because you have been at this much longer than probably a lot of the folks out there, and you've really been around longer than the buzzword at this point, if you lump this into serverless, right? How has that business conversation become easier over time? Because, you know, what we found with some of these emerging technologies, and if you can find folks that have been doing this a long time, sometimes everyone struggles with, well, you know, there isn't a buzzword around it, or there isn't a market around it, or there isn't a bunch of companies that kind of get, you know, grouped together by, you know, analysts or somebody else. And so has that gotten easier over time as this serverless trend has kind of gone to the height it's gone?
Yeah, I mean, certainly as we've evolved as a company since later 2010, early 2011, the conversation has really shifted from why iron to when iron. How fast can I get serverless, or how fast can I get this? But not necessarily on just AWS, obviously, because Lambda has really taken the world by storm. But how can I get this on my private cloud, on my hybrid cloud, and my multi-cloud environment? So the conversation has really changed from like we're trying to shout to the world, this is a really interesting compute model, to everybody understands it now. How quickly can we get it in our environment, which has been a very big change for us as a company. That has also driven our change in our go-to-market, which is now we're not only selling direct to developers on top of the public cloud, but we're selling to the heads of clouds who are building these clouds and want serverless solutions, because their developers are literally asking, we would like serverless computing. We're looking at this compute model, and we need to offer it as a service on our private cloud, or else all of our workloads are going to go to the public cloud. And so that conversation has obviously gotten a lot easier for us over the years.
Yeah. And you bring up an interesting point there too, because so if this is indeed like, okay, if you were going to take, I don't know, some code that was written to run in just say straight up AWS Lambda versus running in an Iron IO environment, because you have that abstraction or that portability, if you will, between on-prem and public cloud, let's just call it Lambda in this instance, are you then writing code to the Iron IO framework, or would that be transferable to Lambda regardless of whether it was Iron IO? Tell us a little bit about how the applications would actually, you know, be developed and perform.
Yeah, I mean, the code is still the same. You take the code and you can zip it up and send it to AWS. You can zip it up and send it to Iron. We support Docker as a first-class citizen. So in our case, you just put it into a Docker container and then put it in Docker Hub or Trusted Registry if you're using a private cloud. The big difference is that you can now trigger that code from any trigger, whether it's on AWS or a different cloud, or a trigger can actually send that workload to a cluster that's running on any public cloud or any private cloud. You have full control and portability over where that workload runs. We can even take Lambda functions directly from your AWS account, inject those into a Docker container, wire those up from other triggers or other services, and then run them anywhere so you become completely portable of where your workload runs. The hard part is if you start to use all the native triggers, which is one of the big benefits, but it also becomes almost the super glue of the service. Like once you have 10,000 Lambda functions all wired up to run off triggers from 2,000 other AWS services that you guys are using, it becomes a very wiry, hairy mess and very anti-portable, or very not portable. And so you have to think about the architecture up front a little bit and give it some thought up front again on a whiteboard. By using something like Iron, you're able to unlock that and run on any cloud.
Yeah. And, you know, one of the things that we were hearing, and it sort of surprised us, and we heard it from, you know, multiple sources, was people were talking about, their sort of compute bill when you can get very granular with this. And they were talking about, 60, 70, 80% reduction in compute costs. And I assume most of that has to do with just you're no longer paying for idle time or forgotten time. Were you seeing similar types of numbers? I mean, just very significant cost reduction in using this model?
Yeah, our customers are definitely seeing a reduction in costs as opposed to managing a number of servers themselves, and running all the networking and load balancing and everything, and having to have the ops folks to manage this. You actually compress that all down into just shipping code and having the system take care of it. So the operational overhead is a lot less. The infrastructure costs become less because we can amortize that in a multi-tenant world across hundreds of other customers or thousands of other customers. But certainly, Lambda has the big benefit of Lambda is they have this massive scale, and their cost model is literally pennies on the dollar. It is almost a commoditized service at this point. And so if you've committed kind of to all public cloud, one single vendor, never going to unlock from that, it's certainly a very economic benefit to be able to use a single service like that.
Right. So it's the classic, if you're willing to, take what they offer you and the conveniences of that may work out very well. And if you're more interested in having some flexibility, that's where the abstractions and the multi-cloud piece of it really comes into play. That makes a ton of sense.
Exactly. And if you are also okay with using the languages that they support and the limitations of the runtime and the error handling, I mean, there's a number of differences and sort of gaps in functionality, but at some degree, it becomes good enough.
Right. Well, and I think
there's some rough edges, but at the end of the day, you can get the job done.
Yeah,
definitely.
Yeah, and I think like we had a chance to talk to the OpenWhisk team, and when they were talking about supporting Docker as well, that made a ton of sense. We see that on the platform as a service side as well, is people say like, look, containers give us the ability to basically run any language, any framework we want. I don't have to be dependent on you delivering a runtime to me. So, I mean, the fact that you guys basically are sort of language independent, or could be, is a big deal for people that are moving, especially if you're moving into these new areas, asynchronous languages and lots of other things that may not be there out of the box.
Totally, yeah. When we started the company, Docker didn't exist, and we ran inside Linux containers. But we did it the same way. You would send code, you would zip code up, send it to us, and we would inject it into a single stack. But it was just so limiting to what you could do. And when Docker came around, we actually announced it at the GoSF meetup that we run here in San Francisco. It was like just the light bulb went off. This is the perfect level of abstraction to pair with functions of the service. The pairing is just almost perfect, where it gives you complete portability, a complete runtime. You can run anything you want, and it just works out of the box, and it runs the same on your laptop as it does in the public cloud.
Right.
Oh, I like that. I like that a lot.
So I would kind of wrap this up, because I know we've covered a lot of topics. I wanted to hit on one last thing. If we go digging through the Iron.io GitHub repo, there's a number of things in there, Docker workers, and there's looks like sort of an open source version of the Lambda framework and some other stuff. What's your guys' overall just sort of philosophy about open source versus the commercial offering? I mean, do you when do you open source things, or what's kind of your thinking around that?
Today we are 100% closed source. We made a very deliberate decision to offer it as a hosted service without any installable code or any fidgeting you need to do, or installation or servers to manage. I mean, that was the true serverless model. But as we are transitioning into the private cloud market and the hybrid cloud market, there's definitely a benefit to having an open source version of your software to be able to integrate with the other layers of the stack. You don't want to be the only proprietary piece of code that sits on a whole open source stack. And so expect some announcements coming soon around open source. We're extremely excited, but have not made them just yet.
Cool.
Oh, great to hear.
what's the best way if somebody wants to engage you guys? They want to get a hold of the software. They want to play around with it, trial it. What are the good ways to either get the bits or just play around with a hosted service version?
Yeah, well, that's the cool thing is you just go to Iron.io and you fire up an account and you're spinning up jobs within 5 or 10 minutes. It's pretty powerful. We're actually, I think we're executing around 2 to 3 million Docker containers per day in production for our hosted customers. And so the system is very battle tested. And then if you like what you see, you like the API, you like the experience, we are adding synchronous to it. Just give us a call. Number is at the top of the website, or send an email to sales@Iron.io or support@Iron.io, and we will engage. We're engaging in a number of proof of concepts now for large enterprise customers and cloud service providers to offer Iron as a serverless platform. So we're very excited for the next chapter of the company.
Very cool. Very cool.
Awesome.
And can we expect you guys to be out at the Serverless conference in London or any other big events coming up?
We are at Cloud Foundry Summit in Frankfurt, and I'm speaking on serverless at the O'Reilly Architecture Conference in London. And then we are speaking at the OpenStack Barcelona conference. And serverless is definitely high on the list. So I'm sure we'll have some presence. I'd love to hang out and talk serverless with anybody that wants to.
Very cool. Very cool.
Fantastic.
Aaron, since you're back, why don't you take us home, wrap it up?
Yeah, absolutely. So just wanted to say very quickly, too, hope everyone likes in listening to some of the serverless stuff. And the Serverless cast is coming. Won't be too much longer, hopefully. Hopefully we got a bunch of the bumps in the road worked out, but we shall see on that one. But yeah, coming soon. But certainly, Chad, thank you very much for your time today. And on behalf of Brian and myself, thanks for listening this week. And we'll talk to everyone next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.